Good afternoon and welcome. My name is John Gloa. I'm a chosen substitution for the usual person that introduces people at these OBSSR lecture series, and I'm here today to introduce our speaker, who is Dr. Jonathan Schooler. He's a professor in the Department of Psychological and Brain Sciences at the University of California, Santa Barbara. He formerly held academic positions in the Department of Psychology at the University of British Columbia and the University of Pittsburgh. He took his BA in Hamilton College earlier, and then a PhD at the University of Washington. And since that time, he's held a number of grants from both federal and private foundations to study a number of concepts around cognition, consciousness, and mental processes. I noted with some selfish interest his interest clearly includes mindfulness, an area of research that I oversee here at NIH. So he may be able to help me find a biomarker for some aspects of that. So he sits on a number of editorial and advisory boards, published over 100 papers in respected journals, but it was his citation of media coverage that caught my attention. Articles like that in the Washington Post entitled, "Too Much Happiness Can Make You Unhappy," or "Cosmic Habituation," or "The Eureka Hunt." And the neuroscience, is neuroscience the death of free will? Perhaps inappropriate for this building, but that illustrate that journalists seem to have made him a center of attention. In fact, one of the articles, "The Truth Wears Off," in the New Yorker, and another recent spot in Nature, which I brought along with me if anyone wants to see it, kind of forespoke the topic of this talk. And I'm going to decline to attempt to steal his thunder along those lines. Instead, just welcome Jonathan, and please tell us more about the decline effect.
Thank you. It's a real pleasure to be here, and an honor to speak to you. I have to acknowledge at the beginning that I'm speaking with some trepidation about this, because for a variety of reasons. One is that in some ways the decline effect challenges science and challenges sort of the way we think about science in some rather fundamental ways, and one always feels a little uncomfortable challenging the mainstream. And then in addition, I'm going to allude to some very controversial research, the kind of research that many of you may be startled to see me even talking about, let alone taking somewhat seriously. And so for those reasons, I acknowledge the trepidation. But I think, and I even considered not talking about some of these lines of research, but I do think that it's appropriate to at least see them in the context of the larger issue that I'm going to be talking about today. So, with no further ado, let's move on and see what I'm getting at here. So, let me begin with a quote from Coelho, who wrote the very popular book The Alchemist, who says, "Every search begins with beginner's luck and ends with the victor being severely tested." And I have to tell you that this has been my experience in science in a whole variety of different contexts, where I start off in a new area and I get some really rather remarkable results, which become then increasingly difficult to replicate entirely. Usually I see them, but they're just not as strong as they were when I first started off. It turns out that this experience that I've had personally, and I'll flesh that out more soon, has been explored in a variety of different domains, and it seems to be a ubiquitous aspect of research that initial attempts are associated with a level of success that is hard to replicate. And that's the thesis that I want to explore with you today. But again, as I warned you, the term was coined and was first identified in the rather controversial area of parapsychology. Rhine, who famously had this parapsychology lab in Duke, was studying a clairvoyant and had absolutely sort of remarkable, statistically significant at some incredible level with this individual. And then as he kept running, the effect got smaller, and he coined the term the decline effect. And then Dean Radin, who's a perhaps one of the best-known parapsychologists, wrote in his book Entangled Minds, "A frequent observation in psi research is that when a new experiment is first conducted, the outcomes are strikingly successful. Then, as others try to replicate, the effect begins to fade." And this basic idea was popularized by Jonah Lehrer in a recent New Yorker article called "The Truth Wears Off." And in this, this actually article came from a discussion he had with me, in which he was interviewing me about some of my more mainstream research on mind wandering and creativity, and I just sort of happened to mention to him that I had this experience of the decline effect, and that I'd observed it in a number of different areas. And he became interested in this and looked into the areas that I told him about, and found indeed that there were striking examples of decline effects, and then found it in other areas as well. So sort of interesting collaboration between science and the media. But as a consequence of this, the article actually went viral. It was the #1 most emailed New Yorker article for several months. I was actually warned before Lehrer wrote it, that if I allowed him to interview me, and if I sort of acknowledged some of these concerns, that it would do in my career, and it still may, but not so far. And in fact, as a consequence of this article, I was invited to, by Nature, to write a piece describing the decline effect. So far, I haven't paid the price, but time will tell. Let me tell you some of my personal experiences with the decline effect. And it may be that I'm just uniquely lucky or unlucky. The decline effect is kind of a peculiar mix of luck and lack of luck, because you hit it first, and then you have a hard time getting it again. But my original dissertation was something known as verbal overshadowing, where it's kind of a fun finding. People witnessed a videotape of a bank robbery, and then they attempted to describe it in as much detail as possible. And then they were given a lineup including a different picture of the perpetrator and several distractors. And what we found, contrary to what you might expect, is that verbal description actually impaired performance quite substantially. And this effect we replicated. It ended up with a 6-experiment series of replications. And other people replicated it, but it became increasingly difficult to replicate. I have to tell you that now I find it very hard to replicate this basic effect that was so easy to get at first. I've experienced this in a host of other paradigms as well. Again, perhaps I'm just uniquely lucky or unlucky. We've gotten it with not only faces, but also with color. We got a really robust effect. That was replicated, but then that was difficult to replicate yet again. With music, with maps, and then in related paradigms, such as thinking out loud while solving inside problems, that disrupted performance, but that's proven to be difficult to replicate. Implicit learning, when people describe an implicit learning paradigm, or when people describe an implicit rule that they've learned, that seems to interfere with performance, or at least it did, but now not so much. Analogical retrieval. So I've been haunted by this experience of getting effects, getting them several times. It's not just like once, but then finding it increasingly difficult to replicate. Now, here's again where I go into the more controversial areas. I was exposed to and was intrigued by some research that Daryl Bem conducted, and decided to follow up on that. So this is having to do with this really sort of remarkable claim that the arrow of time might, under some situations, go in the opposite direction. So physicists acknowledge that there is nothing inherent in the laws of physics that preclude the arrow of time going from the future to the past. Brian Greene, who's a respected physicist, although I doubt very much that he would see this as supporting the idea of precognition, but nevertheless he says, the laws of physics that have been articulated from Newton through Maxwell and Einstein up until today show a complete symmetry between past and future. Nowhere in any of these laws do we find a stipulation that they apply one way in time but not the other. even though experience reveals over and over again that there is an arrow of how events unfold in time, this arrow seems not to be found in the fundamental laws of physics. Not only do no known laws fail to tell us why we see events unfold in only one order, they also tell us that in theory events can unfold in reverse order. And it turns out that there is a area of research known as precognition, which is found in a variety of different paradigms that there seems to be some evidence that people can be influenced by events that have not yet taken place. This is a meta-analysis, admittedly in the Journal of Parapsychology, but nevertheless it involved quite a few studies, 309 studies, 62 investigators, 2 million individual trials, 50,000 subjects, and found a small but reliable effect size which would require a file drawer. 30% of the studies were significant. Importantly, in this field, they publish non-significant results, and there was no relationship between the quality of study and size of effect. This study concluded there would have to be 46 unreported studies for each reported study for a file drawer to account for it. Now, in a more well-respected journal, or at least formally respected journal, some would argue that it lost some respect as a result of this paper being published. Daryl Bem, a well-respected, or at least formally well-respected researcher, published a series of 9 studies showing what appeared to be evidence of precognition in a variety of different paradigms. For example, in one paradigm, people were exposed to had to say how arousing stimuli were, and if the stimulus was going to be presented again in the future, they found it less arousing than if it was not. And this, again, was not just one, but 9 different experiments. So, based on knowledge of this, we decided to try a variation of this paradigm out for ourselves. We did a implicit priming paradigm in which we basically, there's a standard finding in cognitive psychology, which is that if you see an image and then you see it again, the second time you see it, it's more perceptually fluent. You see it more readily the second time. So if that's the case, and if there's something to precognition, then you might expect that if you were to present a stimulus and then present it again, that this, if it's going to be presented a second time, that would actually facilitate its original perception. So in this paradigm, participants viewed a fixation, there was a noise mask, a briefly flashed image, a noise mask again, and then they indicated whether or not they knew what was presented, and then the critical manipulation, on some cases the image was presented again, in other cases not. So it kind of looked like this: fixation point, briefly flashed image. If you know what the image was, press the up arrow. If you don't, press the down arrow, and then it's presented again, or same basic paradigm, but there's nothing. And our original result was small but quite significant, that the primed stimuli, these are stimuli that are primed in the future, were slightly more likely to be identified than the unprimed stimuli. And there were some complications with this zone, so we replicated again, cleaning up a few issues. Again, the same basic result. We replicated this experiment something on the order of, what is this, about 16 times, and as you can see, this is the decline effect. And you'll notice here, it's not just like we got it and then it went away. What we get is this very linear effect, so that it's we get a linear effect, and if you look at the first overall, the entire effect is significant overall, the decline effect at the point 0.00017 level, and if we just look at the second half at experiments 7 through 19, it's still significant, point less than 0.05. So we're getting this rather marked linear decline effect. And things like publication bias and that type of thing really don't apply here, because these were all run in my lab. Okay, so the conclusions from this is that the overall effect also remains significant, but there was this massive decline effect. And the early studies had a somewhat smaller n in them, but even when we take that into account, we still have this significant decline effect. So I'm not the only person to observe decline effects in parapsychology. This is an analysis of decline effects over years in dice throwing. So this is people's ability to influence the outcome of dice throws, and as you can see, there's a decline effect in that. Here is a decline effect in the Gansfeld effect. The Gansfeld effect was actually written up also by Darrell Bem in Psychological Bulletin, a respected journal, in which it's basically a form of telepathy where one person sees an image and another person tries to figure out what the image is, and it's relatively carefully controlled. But what you see here is that the magnitude of that effect declined over time between up until 2001. Now, there's a curious thing about the decline effect is, so here they did an analysis and they demonstrated the decline effect. And so you can ask the question, well, what would happen? You've now demonstrated a decline effect. What happens if you now look to see what happens to the decline effect? Does the decline effect decline? And there's this curious thing where after they found this, there was actually a 2010 article in Psych Bulletin where you see this decline effect, but then in a peculiar sort of way, the decline effect declines and the effect returns. Again, there being an overall significant effect, but the peculiar decline of a decline effect. And again, the same thing in another paradigm of telekinesis. So, conclusions from psi research is that there have been decline effects in a number of different domains. After decline effects have been observed in some domains, the longest studied ones have been, in some cases, a return, and this suggests remotely plausibly that this could be a decline in the decline effect. Now, if the decline effect were just in my lab and just in parapsychology, I would not expect you to take it very seriously. But as I hope to show you, this is not just limited to me and this sort of esoteric field of science. In fact, it seems to be prevalent in a variety of other domains as well. And so this is the really curious thing. And so when we consider the lesson from parapsychology, one possibility is that there is this artifact in science, and that artifact is entirely what drives what's going on in parapsychology. And so you see this decline effect because the decline effect is sort of emblematic of artifact, but that artifact also permeates mainstream science, as I'll hopefully persuade you. The other alternative is that actually parapsychology, there's something to it, and they picked up on something which is also prevalent in other areas as well. And I think it's an open question which one of those possibilities is the case, although I certainly would appreciate that people may have some pretty strong opinions about which one is more likely. Okay, so let's talk about decline effects in conventional science. I want to talk about three different areas where it's been observed: drug treatments, highly cited medical interventions, and biology meta-analyses. So this is, some of you may even know my mother, Nina Schooler, who's worked at NIH for many or NIMH for many years, and has been at a number of other institutions, University of Pittsburgh, for example. And I was in her office one day, and I saw this this article which said, why do the effects of antipsychotic drugs decline over time? I had no idea that this was an issue, but this is a meta-analysis by a number of different researchers, including my mother, Nina Schooler, which basically shows that the efficacy of antipsychotic drugs relative to placebos has declined over time. But this is not the only place in which decline effects have been observed. Bob Kaplan, who unfortunately wasn't able to be here today, who's Associate Director in the NIH Office of Behavioral and Social Sciences Research, has looked at a number of different types of medical treatments in which he's observed decline effects. This is a decline effect in pravastatin to treat cholesterol. Here's a decline effect in timolol, which is a beta blocker. And here's a decline effect in latanoprost, which is a treatment of glaucoma. But that's not all. In a very influential and I think insightful article, Ioannidis looked at the most highly cited medical journal articles, and he found that of the 49 highly cited original clinical research studies, 45 claimed that the intervention was effective. Of these, 7 were contraindicated by subsequent studies. That means it actually went the opposite way. 7 had found effects that were stronger than those of subsequent studies. 44 were replicated, and 24 remained largely unchallenged. So, in fact, over 40% of those studies for which a replication was attempted were either associated with a declined effect size or were outright contraindicated. So these are the most influential studies, the ones that were considered, sort of the best of the best, or at least the most highly referred to, and nevertheless you see this rather marked decline effect. But that's not all. This is a meta-analysis of meta-analyses by Jenyns and Moeller, and they found, they looked at 44 peer-reviewed meta-analyses, and they found that there was a small but significant decline in effect size with the year of publication. And they did find that the first studies had smaller n than later studies, and that could be part of the effect. But even when you have that taken into account, that is, even when you take into account the effect size or due to size of n, you still see a reduction over time. And this just basically summarizes their data here. So here we see decline effects not only in my lab, not only in parapsychology, but also in a variety of other domains, including drugs such as antipsychotics, cholesterol-lowering drugs, beta blockers, treatment of glaucoma, medical interventions, and biology. There are also other analyses going on currently. John Krosnick at Stanford has been looking into psychology findings and also finding lots of decline effects in psychology as well. So, what's going on here? There are a number of possible reasons for the decline effect, and I think that likely when all the dust settles, that the conclusion will be that it's multiply determined, that there's a number of different things that are going on here. So I want to explore some of the different possible effects, and again do this open-mindedly. So Ioannidis's argument was that initial studies often have a smaller n. And he found that among randomized studies that were contraindicated, that they were initially stronger effect sizes were smaller than replicated or unchallenged studies. So, in other words, he found really sort of two different things. One is that the initial studies had a smaller n, and that's one possible reason why you get a larger effect size, because the law of large numbers. And then, in addition, that the randomized studies tended to be later on and the non-randomized initially. And so both of those factors could lead to larger effect sizes initially. He also found that non-randomized studies tend to be unreliable, not surprisingly. And 5 of the 6 highly cited non-randomized studies had been contraindicated or had found strong effects versus 9 of 39 of the randomized. So clearly 2 factors that could be involved are small n in initial studies and a lack of randomization in initial studies. However, that doesn't seem to explain everything, because decline effects have been observed when n is controlled for, as I just mentioned in the Jenyns and Miller meta-analysis, and also decline effects have been observed in many domains where there have been random assignments. So that alone does not seem to explain the declining effect sizes. So what are some other conventional accounts of the decline effect? Well, the most straightforward account is regression to the mean, right? Finding you're going to run a bunch of studies. Sometimes the error variance is going to be in the same direction as the effect size, and when that happens, it's going to exaggerate the effect, and you're more likely to publish it. If it goes in the opposite direction, you won't get a significant result, and so you won't publish anything at all. And so it makes sense that there would be this sort of bias initially for studies in which the error variance goes in the same direction as the actual effect size to be published. And this, I think, is surely part of the story, but it doesn't explain the fact that we see oftentimes this linear decline effect, as opposed to just, if this were the case, you should get one big result and then it should pretty much fluctuate around the mean from there on. So this linear characteristic of the decline effect is hard to explain by regression to the mean. Another possibility, I think this is a very elegant explanation, is what a colleague of mine termed degradation of procedure. And here the idea, Dan Smelik is the one who coined that term. Here the idea is that the effect may depend on the unappreciated importance of arbitrary methodological elements that are not included in replication. So when we run studies, there are all these arbitrary decisions that we have to make. And we don't necessarily appreciate that some of these arbitrary decisions may actually be potent. They may actually be part of what drives the effect. Time of day, or the particular experiment that we're using, a whole host of different things. And these factors may not be included in the methodology, and we may not even appreciate them to be important ourselves. So as the study is replicated, these factors that we don't recognize as being important may be increasingly likely to drop out of the experiment, and that may contribute to subtle changes which nevertheless are important and lead to a dwindling effect size. And this, I think, is a very elegant explanation, and it also has this nice part which it provides one way of conceptualizing the linear quality, because the more time that goes by, the more of these arbitrary decisions are likely to be changed as people don't appreciate them to be important. The one thing that's sort of curious about this explanation is, why are we so lucky at first? Why don't we introduce things that aren't quite right, and as we replicate, you might just as well expect that we'd get it better, that they're arbitrary, that we do it, in the afternoon instead of the morning. That should work for us as often as against us. So it's not obvious why degradation procedure always works for a decline. You'd think that oftentimes these arbitrary things would cancel out and go in the opposite direction. And indeed, you'd think that as people ran the experiment, they'd get the hang of what are really the conditions that maximize the effect, and you'd think that would work in the opposite direction. Another possibility is refinement of procedure, that there may be improved methodologies that remove erroneous sources of positive effects. So part of your effect is really due to something that really isn't the actual effect size, and so when you refine your procedure, you get it better, then these errant sources of effect disappear. But again, shouldn't methodological refinements also work in the other direction? Shouldn't, as people understand effects better, shouldn't that make it easier for them, at least in some situations, to get effects? The fact that our understanding would lead it to be harder to get effects so consistently is hard to understand entirely. Another possibility, and again I think all of these have merit, is publication bias. Published studies and editors and so on are going to favor positive results, and they're quite likely going to favor strong positive results. Let me just introduce some evidence for this. So Bartow and Rillig did a recent, sorry, that says 2002, that should be 2012, did a recent meta-analysis of 3,867 studies, including 52 meta-analyses in ecology. And they found that the first papers published in an area reported the strongest effects, but that if the effect was positive, then the earliest publications reported the greatest positive effects, while if the observed effect was negative, the earliest papers reported the greatest negative effects. Importantly, high impact factor journals published the most extreme effects, and effect size was more important than data quality for many of these publications. And the papers reporting strong effects were often of lower data quality than papers reporting much weaker effects. And high impact factor journals publish the strongest effects generally in the absence of any correlation with data quality. So basically what you see here is a bias for strong effect sizes, and that bias for strong effect sizes may contribute to the publication bias that may lead to this decline effect. So what are some other explanations? The last one is one that's really picked up some momentum in the last year or so, which is this idea of too many degrees of freedom. The idea here is that when we conduct science, there are a whole lot of opportunities for us to make judgment calls about which dependent measures to report, which covariates to use, and so on. And that because we have so many degrees of freedom, they may contribute to sort of our ability to cherry pick our results. And indeed, there was a recent study that came out in Psychological Science with the catchy title False Positive Psychology by Simons et al., in which they made a case for the dangers of these excessive degrees of freedom. And they did this in two different ways. One way was to examine 5 different sources of experimental degrees of freedom, including choosing among dependent variables, varying the sample size, so basically peaking, and if the effect is significant, stopping, and if it's not, continuing, using covariates, reporting a subset of experimental conditions, and then combining these. And then they did a Monte Carlo simulation of experiments to see what would happen if you take advantage of all these different experimental degrees of freedom. And what they found is that if they, let's see, I think I have a table right here. If you take a look at the p less than 0.05 level here, and then you combine all the different experimental degrees of freedom together, their Monte Carlo simulation said there's a 60% chance that you get a false result. So when you take advantage of all the sort of wiggle room that we have as scientists, there's a real opportunity to introduce false positive results. They also did a very clever study in which they exposed participants to a listening to When I'm 64, and they took advantage of all the different experimental degrees of freedom that they had, and doing that, they were able to show that participants reported a younger age when they were exposed to When I'm 64 relative to a control song. And I think most of us would agree that this is very unlikely that listening to When I'm 64 makes you younger. Well, how did they achieve this? And they did two write-ups, one which is where they took advantage of all the experimental degrees of freedom, and the other where they didn't. So this is the write-up where they ignore acknowledging the experimental degrees of freedom. They say 20 undergraduates drawn from the same pool as Study 1 listened to either When I'm 64 by the Beatles or Kalimba. In an ostensibly unrelated task, they then indicated their birth date, and Akova revealed the predicted effect. People were nearly a year and a half younger after listening to When I'm 64 rather than Kalimba. Wow! But what they didn't tell you is all this other stuff. So here they have the original report. It was actually 34 undergraduates drawn from the same pool of Study 1 listened to either When I'm 64 by the Beatles or Kalimba or Hot Potato by the Wiggles. So they left out all these other details. And then in this version here, they show all the things that they left out. So sure, when you only report some of the sample with some of the measures and so on and so forth, you can get significant results. Basically, they took advantage of experimental degrees of freedom. Now, but do people really do this? Sure, maybe this is something that you might do, but people don't actually do this. Well, in fact, in another paper that just came out in Psychological Science, John Lowenstein and Prelick did a survey of over 2,000 psychologists about their involvement in questionable research practices using an anonymous elicitation format supplemented by incentives for honest reporting. There were two conditions. One condition where they received standard instructions, and the other they used this Bayesian truth serum scoring algorithm where they said they would donate a bit to charity if for their choices, and that the size of the donation would depend on the truthfulness of their responses. And this has been shown in the past to be particularly sensitive to those areas where people are likely to distort the truth a little bit. And it's hard for you to see here all the numbers here, but here we have a number of different possible activities, such as in a paper failing to report all of a study's dependent measures. 63% of respondents said that they did that. Deciding whether to collect more data after seeing whether the results were significant, 55% said they did that. Stopping collected data earlier than planned because one found the result that one had been looking for, nearly a third said they'd done that. So virtually all of the degrees of freedom that was identified in the Simons et al. Study, turns out that a significant proportion of researchers take advantage of these, or at least appear to from this survey. So, could selective reporting account for decline effect? It certainly could be an important factor. Initial investigators may be especially motivated to use degrees of freedom to obtain the greatest possible effects. No question it's a major problem for the field, but it does not explain my personal experiences. I've watched doing the exact same paradigm, these effects get smaller. And it also is hard to see how these things would produce this systematic linear decline effects that have been observed across fields. Okay. Here I go a little bit again into the area that I'm hesitant to go, but I can't resist just putting this out there. So, non-conventional accounts of the decline effect. So, if you ask Darrell Bem what he thinks is going on, he suggests that experimenter bias influences effects in some non-conventional ways. So this is basically parapsychology influencing the experimenter himself. So he finds that those there have been a number of attempts to replicate his paradigm, and those people who believe in his effects have found effects, whereas those who tend to be skeptical have found non-effects. And Bem argues that this may be that the actual beliefs of the experimenter is somehow, in a parapsychological way, influencing the outcome of the results. Now, you might think that this is ludicrous. In fact, you probably do. But I asked Bob Rosenthal, who is the person who really discovered experimenter expectancy effects, what he thought about this possible interpretation. And you might be surprised to hear what he said. Keep in mind, for those of you who don't know, Bob Rosenthal is the former chair of the psychology department at Harvard University and a well-respected individual. He says, Daryl Bem is in good company. Gordon Allport also believed that interpersonal expectancy effects might well be mediated parapsychologically. As of today, I have no evidence to support that position, nor do I have evidence to support the position that parapsychological phenomena are not involved in the mediation of interpersonal expectancy effects. Over the years, my students and I have found a number of potential mediating variables, but we are a long way from explaining all of the mechanisms that serve to mediate the operation of interpersonal expectancy effects. So, Rosenthal, who I think is a sane person, thinks it's not inappropriate to keep our mind open to the possibility that somehow, in some way that we don't yet understand, the expectations of the experimenter may be influencing the outcome of results. Okay, if that is not radical enough for you, I can't resist but going one step further, which is that it's possible that somehow the phenomena themselves change as a function of observation. It's known in other areas that, or at least suggested, one interpretation of effects in quantum mechanics is that scientific observations somehow affect a phenomena. And so I don't think we can entirely rule out, although I don't think we should jump on the bandwagon of this quite yet, that genuine effects may actually fade with repeated observation in some peculiar way that we can't yet understand, which would suggest that the laws of nature are not immutable, which again is a very radical view, but one that has also been entertained by physicists. Admittedly, these are explanations of last resort, but I don't think we can entirely rule them out until we get a better handle on the actual source of the decline effect. Okay, so how can we get a better handle on the source of the decline effect? And here's where I think people, even if you totally rule out some of the more radical ideas I presented here, where you may find some sympathies. I think that in order to get a handle on this, we need to have more transparency in science. We need a process to let scientists log their hypotheses and methodologies before an experiment and the results afterwards, regardless of outcome. Right now, there's this tremendous bias in science where only those findings that have been vetted through this process that is quite biased become available. And I really think, and this is something where I think NIH really could play a role, that the possibility, the time has come for us to think about providing a way where all data, regardless of outcome, is ultimately made available, and where scientists, before they run experiments, carefully log what they're going to do, what they're planning to do, and so on. So there'd be a lot of challenges to such a approach. It would require an automated protocol to enable study methods and results to be entered and retrieved. It would require some way to assess the quality of the work, and I think there'd be some opportunities here too. Perhaps there could be some open access commentaries moderated in a manner similar to Wikipedia. It would require a way to assure the qualifications of researchers who use it. It would require the maintenance of a blackout period to protect hypotheses and findings prior to publication. And it would require incentives and perhaps even new rules from funders to take part. But I think that this is not beyond the ken of imagination. I think this is something that could happen, and that if the right incentives were put in place, and if the carrots and perhaps sticks took place, if people felt that this was something that was appropriate to do, that it could be done. And certainly we have the technology to do it. Indeed, Brian Nosek at the University of Virginia has established and is about to enter beta piloting of a website that would actually do all of these things. And as many of you know, there is something rather similar already happening for clinical trials that, although not perfect, has gone a long way towards increasing the transparency of clinical trials. So, What would the benefits of such an open access repository be? It would reveal how published studies fit into a larger set of conducted studies. And this is, I think, one of the critical things. In understanding the decline effect right now, we just don't know how the published studies relate to all this giant mass of unpublished work. It would overcome many of the problems stemming from excessive degrees of freedom. Regardless of what you think about the decline effect, there's this whole issue of excessive degrees of freedom that needs to be addressed. It would make the scientific process much more transparent. We would have a much clearer understanding of exactly what's going on in science, instead of this peculiar way in which we get this sort of cherry-picked version of science. It would likely reveal the source of the decline effect. So, the bottom line. The decline effect has haunted me my entire career, and I wonder how many of you have had experiences of a similar sort. It has also been observed in many domains of science. Many factors are likely to contribute to the decline effect. It highlights the likely impact of questionable yet common scientific practices. And we cannot completely understand the decline effect until science does a better job of making available all studies, not just those that have been tailored for publication. And again, this is a point that I really think is important. I really think the time has come for us to seriously consider some sort of way of increasing the transparency of science, where researchers are expected to make all of their protocols and all of their findings available. An open access repository would go a long way both towards correcting excessive scientific degrees of freedom and revealing the sources of the decline effect. Thank you very much. Yes, Alex. Mm-hmm. Well, I think a lot of the drug studies showing decline effects in those domains would constitute examples of that sort. But I do agree that my expectation is, if you were to look at the Galileo's the rate at which balls have been going down at a certain rate, probably the same rate ever since that was first observed. So there is some category of kinds of experiments that may be particularly vulnerable to decline effects. And if I were to guess what it was, I would say it's the kind of counterintuitive one. So there's a recent failure to replicate some research by John Barge on implicit goals. And I've always said that seems like the kind of finding that you're going to have to get exactly right in order to observe it. So I think your question is a very good one. The drug studies seem to suggest domains that don't seem all that counterintuitive, where decline effects have been observed, but I do think it's the sort of surprising counterintuitive results that may be the most vulnerable. Right. Well, and that's I mean, I've done the exact same paradigm and found harder times doing exactly the same thing, which is again what makes me suspicious. But I think that there are a lot of questions that are open, and that what we really need to do is have very sort of careful analyses in a variety of different domains to see exactly the magnitude of these effects. Yes. Well, It depends how you define subjective. So you find it in ecology, you find it in biology, you find it in medicine. I'm not sure if those are subjective. All of them seem to have some sort of biological, organism involved. So they all involve, but in some of these cases they're with pretty low level life forms. So it's hard to know. I don't know of any good examples of it in physics. But again, physics has this level of control that we don't see in these other domains as well. Yes. Yeah. Yes. But why doesn't so? But that also has to assume that the placebo component is not additive with the drug component, because if there's a placebo component and a drug component, and if the placebo component is going up, why does that take away from the component that would have otherwise been driven by the drug part? You need to throw in that other mechanism in order for that to explain it, and there's no obvious reason why that should be going on. Yes. Yeah, I certainly agree with the first part of what you're saying. I think that a big part of this involves the transparency of the procedure, and as I mentioned, the degradation of procedure. That whole mechanism is driven on the idea that there may be a whole set of things that we think are just arbitrary that are actually proving to be very important. And I also think that because we now have the internet, we have this basically sort of unlimited availability for space and documentation, that there's an opportunity to provide much more details than we could have done when we were limited by the space of paper and journal reporting. So I think we really are in a new age with new opportunities that can really address the kind of transparency issues that you raise. Yeah. Yeah, I think that's a real issue. Um, what happens is that when people see them described as supplemental, they consider it sort of or optional, And I quite agree that that's a big issue, and we need to think about this very carefully because we need to make sure that in increasing the amount of information that's made available, that we don't make reviewing process even more onerous than it already is. So I agree. There's a balancing act that has to be sorted out here. Yes. Yeah. Well, and again, this is one of the explanations that I suggested. It does make sense. That is, if people make errors, that they're going to sort of make errors that are sort of biased towards finding results, and that as they refine their procedure, they're going to get rid of these errant sources of positive effects. And that certainly may well be a significant, perhaps even the entire explanation for the decline effect. But you'd also expect that and this I'm sure is the case in many situations, that as people really understand a phenomena better and they know exactly what causes it and the conditions that are responsible for it, that they should be able to magnify the effect size. So it's not obvious why it would always work in this one direction. You had a question. No, I haven't seen that. Yeah, I can't speak to that. I'm sorry, but it's only been a couple weeks out, so that's my excuse. Yeah, thank you. Yes. Yeah. uh, well, obviously this is therein lies the rub. Um, and there's no simple answers to that. One thing is that in many of these cases, the effect sizes shrink, but they don't shrink to nothing. And so even though I would predict that if you were to do a study looking at the grant proposals and the pilot data and the magnitude of the effect of the pilot data and compare that to the findings that people reported in the ultimately published studies that came from the grants, that you would consistently find that the pilot data had larger effect magnitude than the published studies. But nevertheless, the pattern would have some relevance to one another. And so pilot data, while likely to be exaggerated according to this analysis, is oftentimes at least not going to be entirely moot. Any other questions? Yes. Yeah. So I think the answer to that would be the answer to the decline effect. That I think is sort of the $64,000 question is what is the explanation for the nature of the slope. It seems as if that the decline effect declines to an asymptote that's typically above zero, although in the parapsychology domains it seems to go to zero, and again, that may be that there is some artifact, error variance, something like that, that's driving the effect combined with a real effect, and then as you keep replicating, you gradually dwindle down the artifact and then get to closer to the true value, and in the case of parapsychology, the true value then leads you to zero. So that would be one, I think, viable explanation for what's going on there. But I think that there are a number of other possibilities. And as I mentioned, this peculiar thing in the parapsychology literature, there actually sometimes you get this curvilinear effect where it actually slopes back up afterwards as well. So I think that you've really nailed a critical question that I don't have a definitive answer to. But what I think needs to be done is much more careful, thoughtful, quantitative, experimental investigation of this phenomena so that we can really get a handle on exactly that question. Looks like the questions have declined. Well, thank you very much.